Alright, we're about to set up our 4th axis calibration onto our DM45 CNC mill conversion. You'll notice I've got a pointer here on the 4th axis, and under that pointer is a little black mark, which we'll see later on. If you're using UCCNC, we'll provide you with a default profile that will be close for your application, and also a suggested pin out for your controller. So the first thing we do is go to axis setup, looking at our A-axis, make sure it's enabled. We'll check our step and direction pins, and according to our diagram they're on 7 and 8, which is correct here, and they're on port 3, which is correct. We look at our velocity, and this is set in degrees per minute, so we're going to do 15,000 degrees per minute as the maximum velocity, and our steps at the moment is 110 degrees per, 110 steps per degree of rotation. So if we look at our axis here, you can see the pointer, and we're on 0. We will 0 our axis, type in A360, Now that didn't work because we've got our rollover on 360 degrees enabled. So we'll turn that off to start with while doing the calibration. It's still a rotary axis. So we're at 110. We'll now go A360 again. And I didn't save and load. And we'll try that one more time. That's better. Now you'll see it was close, but didn't quite get there. So we then make this 112. Save and apply that. We'll move our pointer back. We'll 0 this again. And we'll go A360 again. Now that time it overshot it. So we know we're between 110 and 112. So we'll make that 111 this time. Get that pointer back to 0 again. Again, we'll home our axis. And one rotation looks like it gets us nearly exact. Now the problem with an axis is we're doing this by eye. Our eye isn't that great for calibration. So to amplify any errors, we're going to do 10 rotations this time. And if it's out by 0.1 of a degree, or 0.2, that will make it 2 or 3 degrees out at the end of the rotations. So we'll go A36,000, 3,600, that will do 10 rotations. And you can see we undershot it very slightly, so we need to increase this value. We're at 0.2, save those settings and apply. We'll get our pointer back to 0 again, and we'll repeat that. This time it overshot it very slightly, so we know our correct value is somewhere between 111 and 111.2. So we make this, so we're right in the middle. We'll go back, get our pointer lined up again. And we'll do this one more time. I'll stop that because it didn't save. We'll bring our pointer back to where it needs to be. Home our axis again, and we'll do that one more time. And that looks to be very close. Now for most applications that's most very close enough. If we're out by 0.1 of a degree, we would be 1 degree out here on the pointer. I'd like to take that a bit further and do 100 rotations. So we do 36,000. A 36,000. And this will take about a minute and a half to do. Now the beauty of doing 100 rotations is that if it's out 0.1 of a degree, that will mean it's 10 degrees out of the pointer. So we know we can get our accuracy within a very high degree of accuracy by doing that. And we can keep moving these numbers. I know for a fact this machine runs 111.11111. Now if we put 111.12 in, we'd be slightly over. Put 111.10, we'd be slightly under. And we can keep honing that in to get the exact number we want at the level of accuracy we want to achieve. And you see we're halfway there so far. And because we've only got 111.1, I would assume this is going to be a very slight amount under the set point when we finish here at the 100 revolutions. And as I expected, it's slightly under. Now if we made that 111.12, it would be slightly over. So I know for a fact on this machine this is the correct setting. What I would normally do now is take that back to 0 again. I'll make that do 1,000 revolutions and walk away and leave it for 5-10 minutes to do it. Come back and I'll find this point will be exactly on every time. So as you can see, we're out, after 100 revolutions, we're at 2.997 degrees. So we divide that by 100, our accuracy is within 0.02 degrees, which is more than sufficient for a hobby CNC machine.